Let's continue our lecture with chapter 2, carbonyl group. Aldehyde and ketones are referred as carbonyl compound. Carbonyl compound has a carbon atom and oxygen atom connected by a double bond. The general formula of aldehyde and ketone is CnH2nO. For aldehyde, a carbonyl group attached to an alkyl constituent and hydrogen, R C double bond O H. And for the ketone, a carbonyl C double bond O group are connected to two alkyl group, R C double bond O R prime. R is referring to the alkyl substituent. Naming of aldehyde. First step, you need to find the largest carbon chain containing the aldehyde functional group. And then the functional group C.HO can only occur at the end of the chain. Carbon atom of the C.HO is considered as carbon number 1. You need to use the numbers to give the position of the aldehyde and change the E ending of an alkane to Al. Okay, for example here, when you count from right to left, you will get this answer. And you count from left to right, you get this answer. Then you need to compare between both answers, which one is correct. So let's take a look of the location of the aldehyde group. Here is the location number 1, here is the location number 5. Which one you should choose? Okay, always remember, normally the location of the functional group should be the lowest one. Okay, this is the correct answer because the location of the functional group here, which is C double bond OH, is at location number 1. Or it can be written as this structure, or we call as a condensed structure. Okay, please take a look at question A. Okay, here you have how many carbon in the structure? 1, 2, 3, 4, 5. So at location number 5, you have chlorine. And at location number 1, you have double bond O, C double bond OH. So the answer should be 5-chloropentanal. After that, for question B, you need to find the longest parent chain that contain carbonyl compound. 1, 2, 3, 4, 5, 6, 7. Okay, so you need to count from here. So 1, 2, at location number 2, you have bromine group. So it will be 2 bromo. 1, 2, 3, 4. At location 3 and 4, you have methyl group. So 3 and 4. And then at the same time, this methyl group, you have 2 methyl group. Then you need to put dimethyl heptanal. So always remember, in between number and number, you need to put comma. In between number and alphabet, you need to put dash. For aromatic aldehyde, or we call as C double bond OH, when it's combined with benzene, the name changed to benzaldehyde. Naming of the ketones. First, you need to find the longest carbon chain containing the ketone. After that, use number to give the position of the ketone and change the E ending of an alkane to a non. For example here, so you need to try first, is it to count from left to right or right to left? Okay, when you count from right to left, you get this answer, 5-heptanone. And then when you count from left to right, the red one, you get this answer, 3-heptanone. And then you need to compare between these two answers, which one is correct. And you should choose this answer because the location of the functional group is the lowest one, which is at location number 3. This is the correct answer. Isomerism in aldehyde. Aldehyde with 4 carbon atoms or more than 4 exist as structural isomerism. Structural isomerism, or we call as molecules that have the same molecular formula but different structural formula. For example, here you need to draw possible isomer for molecular formula C4H8O. So here, the number of carbon in the structure is same. 1, 2, 3, 4. Here also 1, 2, 3, 4. And also the number of oxygen and hydrogen also same. But the arrangement of the carbon is different from this one and this one. Okay, this is we call as isomer. Aldehydes are also isomeric or functional isomerism with ketones. For example, here you have C3H6O may be a propanal 1, 2, 3. Propanal, which is aldehyde functional group, or propanon, ketone functional group. Means that the number of carbon and hydrogen and also oxygen in both structure is same. But the location of the double bond is different from this one to this one. And this is the application, or we call as industrial importance of aldehyde and ketones. Normally, formaldehyde is used to preserve dead animals, and acetone is a nail polish remover and is used as a solvent. And 2-butanone is used as a solvent and paint stripper. Benzaldehyde is an almond extract. And finally, vanillin is the vanilla flavoring. And for other aldehyde and ketones of industrial significance are mainly used as solvent, perfumes and flavoring agents, or as intermediates in the manufacture of plastics, dyes and pharmaceuticals. Okay, we continue to the method preparation of aldehyde. It's involved the oxidation of primary alcohol. Okay, the starting material is alcohol. The primary alcohol react with pyridinium chlorochromate in the presence of dichloromethane that act as a solvent here. So it will oxidize the primary alcohol to the C double bond OH. And here, so you get here is ethanol. Preparation of aldehyde from acyl chloride. Here you have acyl chloride. You react with lithium aluminium tri-third butoxide hydride is a mild reducing agent. So means that here you reduce the chlorine here to the hydrogen to produce aldehyde. And for the oxidation of secondary alcohols are oxidized to ketone. So here you have a secondary alcohol. This carbon is attached to one carbon at the left and one carbon at the right. So this carbon is categorized as secondary carbon. Hydroxyl group that attached to the secondary carbon is called as secondary alcohol. Okay, when this secondary alcohol react with potassium permanganate in the presence of acid at very high temperature or reflux, so you will get ketone. So the OH will be oxidized to double bond O. For example here, you have 2-propanol when it reacts with potassium dichromate in the presence of acid and then you heat. So this one will oxidize to double bond O. And preparation of ketones, or we call as Friedel-Crafts acylation. Okay, benzene will react with acyl halide or acyl chloride here in the presence of aluminium trichloride. Okay, this compound act as catalyst to boost the reaction and to make the reaction become faster. Okay, at the benzene ring here, you have one hydrogen. This one hydrogen will be substituted with this acyl group, C double bond O R. So at the end of the reaction, so you will get ketone. And finally, after this, we will continue our lecture with reaction of aldehyde and ketone. Thank you.